In this video, we'll be talking about Venn diagrams. The Venn diagram we have on the screen has two sets, set A and set B. And then we also have the universal set, represented by the box around the outside. We've labeled the regions inside 1, 2, 3, and 4, and we'll refer to those as such. So let's say we're given that the number of elements in set A is 5. The number of elements in set B is 4. The number of elements in A intersect B is 3. And the number of elements in the universal set is 10. And let's say what we want to know is how many elements are in the union of A and B. Now from last time, we know that the union of A and B means the elements that are in A or in B or in both. And so what we may think we want to do is just take the two numbers and add them together, the number of elements in A and the number of elements in B. But doing just that doesn't quite work, and so let's look at why. Let's go ahead and label our entire Venn diagram. The number of elements in A intersect B is 3, so we should start there if we have the intersection. And so that's region 2, has 3 elements. Now set A, we know in total has 5 elements. We know 3 of those elements are in region 2, so 2 of those elements would have to be in region 1. Looking at set B, we know set B has 4 elements in total. 3 of those are in region 2, leaving us with 1 in region 3. Lastly, we know the universal is 10, so that should be all of our regions added together. So 2 plus 3 plus 1 plus something should give us 10. And so 2 plus 3 plus 1 is 6. So that leaves us with 4 for region 4. Now, back to our question of how many elements are in A union B. So if we add 5 plus 4, what we're doing is we're taking everything that's in A, which I'm shading in red, and adding it to everything that's in B, which I'll shade in blue. And you can see what we're doing here is we're adding A, which is 2 and 3, to B, which is 3 and 1, and so we've added this 3 twice, so we've double counted it. We don't want to do that. So since we've double counted it, what we can do is subtract it out here. You get 5 plus 4 minus 3. That gives us 6, which would have been the same thing we would have gotten if we just went up here to our Venn diagram and added those numbers together. 2 plus 3 plus 1 also gives us 6. And so this is the union rule, a formula that we'll use pretty frequently from here on out. Number of elements in A union B equals the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Let's look at another example of a Venn diagram problem using the same numbers as we had before. So set A had 2 in region 1, 3 in region 2. Set B had 1 in region 3, and then we had 4 in region 4. Let's say we were asked to find the number of elements in A complement union B. So what that says is we either want the elements that are not in A or that are in B. And so the way we can do that, one way we can do that, is by marking the regions. So first of all, the things that are not in A. So let's mark those in blue. So the things not in A, that's right here and right here. Those are not in A, so those are in A complement. And let's mark what's in B in red. So what's in B? Well, that's regions 2 and 3. Region 2 and 3, those are both in B. Now if you recall, the union means the things that are either in A complement or the things that are in B. So that means anything we marked at all. And so we can just add those numbers together. So 3 and 1 and 4, that gives us 8 elements. Now, if we wanted to find the number of elements in A complement intersect B, those would be the elements that are both in A complement, which we marked earlier in blue, regions 3 and 4, and in set B, which we saw were regions 2 and 3. So the elements that are in both of those things would be the things we marked both blue and red. That's region 3 here. That's only 1 element.